called OR gate. It is a logical electronic component which outputs 1 or true whenever there is a 1 or true in one of its inputs or in both ones. OR here works like English conjunction, or in sentences like this one or that one or both. This could be easily understood looking at the truth table. Here we can see on the right all the possible values of inputs, and on the left the corresponding output values. The truth table offers a complete description of how the gates works. Now I want to show you another logical component, and before doing that I copy the circuit and make an identical copy here, and then I remove the OR gate and I replace it with another gate, AND gate, this one. So let us see how it works. When there is 0 and 0 in input, the AND gate output 0. When we have 0 and 1, in the same way, the output is 0. And when we have 1 or 0, it's always 0. And the only case in which we have a 1 or true in output is when both the inputs are 1. So let me correct the truth table. 0 and 0 is 0. 0 and 1 is 0. 1 and 0 is 0. And 1 and 1 finally is 1. So the AND works like the AND conjunction in phrases like I take a pizza and a beer. So both. Note that the output is always false whenever one of the two inputs is to 0. So, in other words, if one of the two inputs is equal to 0, the output is 0 regardless of the value of the other input. So you see, this is 0, it doesn't matter which is the value of the other input, because the output is always 0 when one or both the inputs are 0. So, in conclusion, let me show you the reason why these components are called gates. First of all, I want to use a clock generator. We briefly encountered the clock generator in one of our previous video, so let me show how does it work. I go to simulate and ticks enable. So you can see the clock generators is a component which produces a repeating sequence of 0 and 1. So now I make a copy of this circuit and I replace one of the two inputs with the clock generator, so here. And you can see that in this case the AND doesn't allow the signal to pass through the gate, because here there is a pulsing signal, so a sequence of 0 and 1, and here we have always 0. But if I put a 1 in this input, you can see that the output is absolutely equal to the clock generator. So in this case, our components works like a sort of gate, and this is the key or the control of the gate. When this input is 0, the gate is closed, so the signal couldn't pass through the gate. And when this input is 1, the gate is open, and so you can see the clock can pass through the gate. This is the reason why this kind of component are called gates.